Hi there, my name is Joseph Burke. I'm a math and physics tutor with Wyzant, and I'm going to answer the question for you today. Find the line of intersection of two planes, and they give us the equation of the two planes. And while I don't have time to answer every detail of this solution in this approximately 5-minute video, I will get you started on how to solve a problem like this by giving you the outline of the steps for part A. So as I do this, I'm going to be talking about things like cross products, position vector, directional vector. I'll be talking about a particular type of equation for a line in space. If you don't know how to take a cross product, or you're not sure of some of the other concepts, then you'll want to get with a great Wyzant tutor after this recording, or maybe even before. So I'm going to share my screen with you because I'm going to be using the equation editor, and I want you to be able to see exactly what I'm doing with that equation editor. Okay, so my screen will change in just a moment. There it is. And the equation editor will allow us to first of all determine if these planes are in fact cross at all. If they're parallel, they don't cross. Well, how do we know this? Well, we know this if the ratio of the corresponding coefficients of the normal vectors are constant. So the coefficients of the normal vectors are the same as the coefficients here that define the plane. And so we're just going to compare the corresponding coefficients and see if they form the same ratios. And I think you can see pretty quickly that they don't, which means that they're not, the planes are not parallel, which means there is in fact a line of intersection. But I'll show you more explicitly what I'm speaking of. So there we have it. We're going to create a fraction with the x terms coefficients, the y terms coefficients, and the z terms coefficients. So for the x terms, that's 3 over 3. So if this is the case, then it'll also be true that this is equal to negative 5 over 3. Well, I think you can already see that 3 over 3 is not equal to negative 5 over 3, and that should be equal to 4 over 2. And we can plainly see that this is not the case. This is not equal, right? So we already know that this problem's a go. These planes are not parallel, therefore they do cross, therefore there is a line of intersection. So the first thing we want to do is we want to find a position vector for this line, which is any point that both planes share. Well, how can we do that? Well, it starts with the equations for the lines. So we've got our equation 3x minus 5y plus 4z equals 6. And we also have the equation 3x minus 3y plus 2z equals 4. A few less spaces. Okay, so we'll just live with this. So here's our two equations. Make it just a tiny bit smaller to fit on the page. Okay, there we go. And what you'll notice is that we've got two equations and three unknowns. Well, that's not going to help us out. But what we only need a point. We don't need to find every point. We need one point on this line. And so what I'm going to do is I'm going to say, well, I want a point where z is 0. And what that's going to do for us is it's going to give us one less variable to worry about in our two equations. So I'm going to copy this. I'm going to paste it here, and I'm going to edit the equation. Now, if z is 0, what happens to z terms is they become 0 because anything times 0 is 0. And so now you see what we have is we've got a system of two equations with two unknowns. Our two equations and our unknowns are x and y. And I'm sure you can solve a system of equations with two unknowns. And if you do so, I'll leave that up to you. You're going to get x is equal to 1/3 and y is equal to -1. So dot, dot, dot. This is something that I have not shown you yet. I have not shown you that you have to be able to do. But now we know that there is a position vector when x is 1/3 and y is -1 and z is 0. So one way we make a line, we draw make a statement that defines a line in space, is we use a positional vector plus a directional vector times a variable t. So now we need the directional vector since we have the positional vector. So the directional vector we define as the cross product of the normal vectors of the plane. I certainly don't have time to do that. That's pretty involved. But if you do that, you will get a vector. I'll go ahead and tell you what it'll be so you can check out your answer. It'll end up being 2, 6, 6. So you have to know what a normal vector to a plane is, and you have to be able to take a cross product. But if you do so, then it's just a matter of taking your position vector, and this is one notation for a position vector, plus your directional vector, and you can use the same notation for a direction vector, times t. And that could be our line of intersection. We'll call it I for intersection. All right, that's our line of intersection. So that is the general outline for finding the line of intersection of two planes, where you determine that the planes are not parallel. And then you can find the position vector by defining one of the variables as 0 and solving the system of equations. And then you can find the direction vector by taking the cross product of the normal vectors of each plane and then creating your formula. Hope that gets you a real good start. If that doesn't help, then please call a Wyzant tutor and plan on spending a good deal of time. Thank you very much. Talk to you later.